Hello everyone, welcome to this video lesson. In this video lesson, we are solving a problem from electric potential. The problem is like this: there are three shells A, B, C, each of radius small a, small b, small c. So this is the inner shell of radius A. This is the next shell of radius B. This is the next shell, outermost shell of radius C. C is bigger actually. The middle shell is earthened. It was given that the middle shell connected there is earthened, connected to that of a ground. When that middle shell is earthened, whenever we earthen it, what happens is, when earthened, potential there becomes 0. So the potential of that middle shell on the outer surface is equal to 0. Charges of Q and 2Q are given. Here is a charge Q given. Here is a charge 2Q given. Right? What are the charges on the inner and the outer surfaces? First of all, as you have given a charge Q on the first shell, it will induce a charge of minus Q on the inner surface of the second shell. That will further induce a charge of plus Q on the outer surface of the second shell. That will induce a charge of minus Q on the inner surface of the outermost shell. That will induce a charge of plus Q on the outermost surface of the outer shell. That won't happen with this 2Q because it's already on the outer surface. All this induction happens onto the outer layers, not to the inner layers. But that is another point. This is earthened, connected to the earth. As it is connected to the earth, some charge from the earth flows from the earth to that surface, QE, so that its potential becomes 0. This QE will induce a charge of minus QE on the inner surface of the outer shell and plus QE on the outer surface of the outer shell. This is how induction produces charges. Now, before I write an equation for the potential of the B, what we can write is, what is the potential of the B? We will write, right? Potential on the surface B is 0, as earthened, as we have explained earlier. Potential on the middle shell is, due to this charge Q, because inside that minus Q and plus Q of this induced charges cancel each other, therefore there is no charge theoretically inside the shell. It is always there on the outer surface of the outer shell. That is the second shell. There is some potential. That is how much? 1 by 4 pi epsilon naught. I am talking about actually this Q, because these two will cancel and it becomes 0 effectively. 1 by 4 pi epsilon naught Q by B. Why? The radius of that surface is B. On the surface of the shell as well as inside the shell, the potential remains constant, that is 1 by 4 pi epsilon naught Q by R. As there is no charge inside a spherical shell, electric intensity is 0 and hence potential is equal to the potential of the surface itself. Plus, there will be electric potential due to this charge. How much is that? 1 by 4 pi epsilon naught QE by B. That's the other one. And there is another electric potential due to this 2Q. How much is that? What we can say is 1 by 4 pi epsilon naught 2Q by C is equal to 0. These are the existing charges because of which this much of a potential is generated. So even if you take the induced charges into consideration, all of them will anyway cancel each other. Therefore, the effective charges taken into consideration is more than sufficient. Q and 2Q are the given charges. QE is the charge that is bumped into the system from the earth. All this has to be equal to be 0. That implies Q by B plus QE by B plus 2Q by C, because that's the outer shell. Charge inside as well as outside remains constant, equal to the potential on the surface of the shell, equal to 0. So what we can say, Q plus QE by B equal to, let me rearrange the terms properly. What we can write, we need to calculate how much is that QE is. So QE by B equal to minus Q by B minus 2Q by C. That implies QE equal to minus Q by B minus 2Q by C into B. That is equal to minus Q, B and B will cancel, minus 2Q and B by C. We can call this in the other way as minus Q of 1 plus 2B by C. That is the charge. It's a negative charge has flown from earth to that surface, so that the potential of that surface becomes 0. Now, having knowing it, we can solve the problem further. You want to find out what is the charge inside the inner surface of the outer shell. We know on inner surface of outer shell, total charge is this charge minus Q, this charge minus QE. So minus of minus Q minus QE, that is minus Q minus QE means minus of this minus becomes plus, plus Q of 1 plus 2B by C. So this value will become minus Q plus Q plus Q into 2B by C. Minus Q and plus Q will cancel. So Q into 2B by C is the charge that is there on the inner surface of the outer shell. We also want to find out what is the charge on outer surface of outer shell. We know on the outer surface, if you see, there is QE plus, there is QE plus, there is 2Q plus. So the total charge there is equal to automatically Q plus 2Q plus QE. Q plus 2Q is 3Q plus QE is this much. So instead of plus I can write a minus, minus Q of 1 plus 2B by C. So 3Q minus Q minus 2B by C into Q. So 3Q minus Q is 2Q minus 2BQ by C is the charge that is there on the outer surface. This is how we can solve the problem. Thank you for watching. Keep coming back for more and more video lessons. Thank you.